4 million suns. That is the mass of the black hole at the center of our galaxy. It is also the faintest black hole of its size that anyone has ever found. Not faint because it is far. It is the closest supermassive black hole to Earth, 26,000 light-years away, inside our own galaxy. We have photographed it. Faint because it is barely eating. A black hole this large should be pouring out light. Ours radiates roughly a billionth of what the physics allows. We know what these objects look like when they are awake. TON 618 outshines the entire galaxy around it. The black hole inside Phoenix A heats the gas between hundreds of galaxies and shuts down star formation across millions of light-years. Ours does almost nothing, and that should not be possible, because the food is right there. Its name is Sagittarius A star. The question is not what it is. The question is what turned it off. The galactic center is buried behind its own dust. In visible light, there is nothing to see at all. So astronomers stopped looking for the black hole and started watching the things around it. There is a star there called S2, a hot blue star, roughly 15 times the mass of the Sun. What matters is its orbit. S2 goes around something invisible once every 16 years. At its closest approach, it is moving at 3% of the speed of light. Nothing accelerates a star to 7,000 kilometers per second except mass. A great deal of it packed into a very small space. Track S2 for one full orbit, and the numbers fall out. 4.3 million solar masses held inside a region smaller than our solar system. There is only one thing that can be that heavy and that small. The astronomers who tracked those orbits won a Nobel Prize for it in 2020, but we had still never seen it. In May of 2022, that changed. The Event Horizon Telescope is not one telescope. It is a network of radio dishes, Hawaii, Chile, the South Pole, linked so precisely that they function as a single instrument the width of the Earth. It needed to be. From here, Sagittarius A star's shadow is about 50 microarcseconds across, roughly the size of a donut sitting on the surface of the Moon. What came out was a ring, a smear of orange light with a dark hole punched through the middle, and the hole is small. The event horizon is about 17 times the width of the Sun. The entire boundary, the point past which nothing returns, would fit inside the orbit of Mercury. But the picture answered the wrong question. It told us it was there. It did not tell us why it was so dim. Here is what makes Sagittarius A star so strange. It is not sitting in an empty room. It is one of the most crowded places we know of. Millions of stars packed into a few light years. Among them are Wolf-Rayet stars, enormous, dying, shedding their outer layers into space in continuous winds. That gas is falling toward the black hole right now, captured by gravity, on a trajectory that ends at the event horizon. Almost none of it arrives. Measure what gets captured at the outer edge, then measure what actually crosses the horizon, and the numbers do not match. Less than 1% makes it in. The rest turns around and leaves. This is the part we do not understand. The leading explanation is that the gas never settles. Instead of a dense, cool disk spiraling inward, it forms something thin and violently hot, hot enough that the particles can escape. The material heats itself faster than gravity can pull it down, and it blows itself back out. The black hole is not full. It is not finished. It is surrounded by food it cannot hold on to. And it has been like this for as long as we have been able to look. We have only been able to look for about 50 years, Point an X-ray telescope at Sagittarius B2, a molecular cloud about 300 light-years from the galactic center, and it glows. Not because anything inside it is hot. It glows because it is reflecting something. Light echoes work like sound in a canyon. Those X-rays left their source, crossed 300 light-years, hit the gas, and scattered back toward us. So we are not seeing what the galactic center is doing. We are seeing what it did. Within the last few centuries, Sagittarius A star was around 1,000,000 times brighter than it is today. Centuries, not millions of years. When that light left, human beings were already writing things down. They simply had no way to see it. And that flare was the small one. Now look above and below the plane of the galaxy. There are two structures there, invisible to the eye, detected only in gamma rays. They are called the Fermi bubbles, and each one reaches 25,000 light-years out from the galactic center. Together, they span half the width of the Milky Way. Something inflated them. Something at the center, millions of years ago, released enough energy to push two lobes of superheated gas out of the galaxy entirely. There is only one object at that location capable of doing that. The quietest black hole we have ever measured is sitting inside the wreckage of its own explosion. It is not dim because it is weak. It is dim because it is between meals. In 2011, astronomers found a cloud of gas falling toward the galactic center on a path that would take it directly past the event horizon. They named it G2. The prediction was straightforward. In 2014, the cloud would be torn apart, the debris would spiral in, and Sagittarius A would light up for the first time in living memory. Telescopes were booked years in advance. 2014 came. G2 rounded the black hole, and nothing happened. It survived, held together most likely by a star buried at its center that nobody had accounted for. It sailed past and kept going. So we are left with an object we can measure precisely and cannot explain. We know its mass to within a fraction of a percent. We have its photograph. We know the shape of the shadow, the size of the horizon, the speed of the stars whipping around it. We do not know why it is asleep. We cannot explain what woke it a few centuries ago. We have no idea what tore two holes through the galaxy millions of years before that, and we do not know what wakes it next. But every galaxy we look at has one of these at its center. Most of them are quiet. A few of them are not. And now we know the difference between the two is not what they are. It is what year you happen to be looking. Subscribe to Curio and explore the universe with us.